This example, we're looking for a way to find the solutions or all the solutions to a specific trig equation. So let's back up a second and let's think about finding the solutions for one rotation on the unit circle. All right, so we're going to kind of make some connections and then we're going to bring it back to just using the unit circle, okay? So if I'm just looking for one rotation of the unit circle, I'm really looking for the solutions for just this piece. Okay, so notice that that's from 0 to 2 pi. Okay, so if I'm looking for where's the cosine of theta equal to negative square root of 2 over 2, well, that's going to be, do you know what negative square root of 2 over 2 is? Negative square root of 2 over 2 is approximately negative 0.7. All right. All right. And so you would probably know this from your use of the unit circle. Well, that's going to be at 3 pi over 4 up in the second quadrant and 5 pi over 4 in the third quadrant, where the x value is negative square root of 2 over 2. All right, and so how we represent this on a graph is going to be right around like that. Okay, so everywhere that this line of negative about 0.7, which is negative square root of 2 over 2, crosses, so 3 pi over 4 and 5 pi over 4. So if you were looking for the answers within one rotation of the unit circle, or it will say find all the answers from 0 to 2 pi, then your answers would be what, 3 pi over 4 and 5 pi over 4. Okay, so now let's think about finding all the solutions, okay? And that's where we're going to bring that other piece back in. Oops, dang, didn't mean to do that. Okay, so I'm going to cover this up. Well, actually, I'm just going to put it where it belongs. Let's see if I can match it. It's good enough, right? Okay, so now if I'm thinking about extending this to the entire graph of y equals cosine of x, actually, let's see if I can. Can I bring this down? There we go. So if I want to think about extending it for the entire graph, and this is still not the entire graph, right? Because this goes infinitely to the left and to the right. I can think about, well, what happens when I extend this to the left, right? And to the right. Notice that I'm going to get some more solutions. And they're going to have this pattern, right? You see you got 2 together here, and then you got 2 together here, and you're going to get 2 together here, and you get 2 together here. Well, those are always going to be a distance of 2 pi apart, because the length of one cycle of cosine, is 2 pi. Okay, and so what we do to represent the entire set of all solutions is we say, well, here's one solution, and then we add this adder that says, and then every 2 pi units, we're going to get another solution. So we say plus 2 pi k. Okay. Okay, did you get that? That was a little math joke. Okay. All right, and this is saying Okay, so, and k is an element of the integers, so that's what that means. K is an element of this funky z means the set of all the integers. Okay, that means I can multiply this k value by any integer and I'm going to get a solution. In other words, I can go from this initial solution of 3 pi over 4, I can go 2 pi units to the right, and then I can go 2 more pi units to the right, and then 2 pi units more to the right, and just keep going infinitely, but they've got to be all whole values. And if I'm going to the left, I am going to have negative whole values, and so that means that these values must be integers. All right, and so that's what's going on with this notation. So long story short, I'm hoping that the explanation is helping you with the why of what we're doing. You find the solutions on one rotation of the circle, and then you're going to add the period of that function times k. And I think that this is already part of what is present in ALEKS. But when you continue, when you just write it this way, it's going to encompass all the solutions for that equation. So make sure that you find, there's usually 2 solutions on the unit circle for one of these equations, but sometimes only one if you're going to be on an axis. Sometimes none if you end up with something that's greater than 1 or negative 1 here, because remember that cosine function has a max of 1 and a min of negative 1. But then this adder represents how we communicate all the solutions. Hope this helps you. Take care. Bye-bye.